Hey guys, let's do the continue the reverse linked list problem that yesterday we spoke about, and this is we just did a iterative implementation yesterday, but today I wanted to follow up because as the lead code is pointing here follow up, and we being good kids we have to follow up the lead code. So let's try to see if we can do the reversed either iterate or recursively. So let's try to do a recursive implementation and see if we can make some progress today. So basically what we need to understand is in the recursive implementation, we can call a function recursively. And as you know, all recursive implementations have a base case. So how can we, I think yesterday we had left at this point without actually completing this, or we might want to do the what we could do is first of all what is our strategy going to be. Now this function expects a return value of a node star, and it takes the head which is the node star, which is the front or the first link in the link list. And so what we can do is, what if I write a some kind of a stub? So basically this should become some kind of a stub function where it only invokes another. It's not really a stub, but I would say more like a wrapper, which basically invokes another function which is truly recursive. So how about, imagine if we had something like return just another function, like imagine it is, we call our function as reverse, just reverse, and we pass the head pointer and the what would be the, let's see, so why do we have to pass the null? So before we before we start invoking it, we should have first written the function prototype for that. So what my idea is, we can what we should do is that we should write our reverse function, which is a truly recursive function, and it takes node star current wherever we are and the node star prep. Don't get confused between node and this structured list node. They are basically one and the same thing. As you see, just for the sake of not having to type all that, I've gone ahead and defined the type def here. So now let's try to implement reverse. So the base case, let's see, the base case is going to be that if current equal to null, what we should do, we can just return the previous, because if we have reached the end of the list, now let's go back to this example here. If we are at this point C here, suppose this is C, if we have reached, if the current starts from A, it moves to B to C, and then it is at the null pointer, there's no point in doing anything else. And if we have really reversed the direction of all these links, then C, or in that case would be the previous pointer, would be the new head, and that's what we need to return. So we say if current equal to null, we can return. Now we need to call the reverse function. It's again inside itself, and which is done by saying reverse. Now the new current we need to check. We need to move on to the next list. So we say, suppose we say node star rest, or the next equal to equal to cur next, right? And prep is already there, so we don't have to define that again, declare that. And prep is the current, obviously, because prep has moved to one step ahead in the on the right, going from left to right. So now then all we need to do is pass our new current and the new prep. Is that making sense here? Now before we say, all we need to do is that next we have already taken, oh okay, so one more problem here is that we have not turned the direction. So that is cur next now should be equal to what? Prep. So cur next is prep. This is actual, frankly speaking, this is the real reversing of the list happening in this case, because we are basically pointing it backward now. So we can write a comment here saying uh, point the current next to backward, and this is the most, I would say, the this is the soul of this function. Reverse is pretty much this line here, and so this is the current next equal to prep, and then so this is the pointing it backward, and after pointing it backward, um, but before we pointed it backward, we had already saved the rest of the list. Some people also like to call it rest, because this is like the rest of the list that we're working on, and we can rest, and this is the previous. So if that is what makes it more clear to you in your mind, then let that be the case, and let us see if that works. So first thing we can do is we can comment out all this code, and easy and fast way to comment out and see is if 0 and if all that code is basically will not be compiled now. And let us see now. So we see here that when we try to run our code, we have a problem. It's saying on line 43 he was expecting, okay, so that can be fixed. Now we run again, see what happens. Again we have a problem. Control reaches end of non-void function. So what is the problem here? We forgot to do a return here. So this recursive function keeps calling itself, but at the end of the day it returns the previous pointer. So it has a return value of node star. So we need to do a return reverse, not just the reverse, because it's not a void return type. Let's do it again, and there you go, it is accepted. And now let's do a submit, and as you can see, it has passed all the test cases that LeetCode had. So here we are. This is a recursive implementation of reversing a singly linked list. Basically, I would say if you were to keep that in your mind for the long run, it's just basically calling a making the original function some kind of a wrapper, but calling a function which by doing which returns the previous pointer when all the nodes are here. As you can see, line 41, they are pointed backward, and every time you basically and the function signature, you should keep that as the current and the prep. And in the beginning, the current is head and prep is null. So I think that's pretty much, if you can somehow get to the grip of that the function signature have to be current and the prep for the reverse function, call that from the wrapper function, then you should be good to go. So with that, I would sign off for today, and then I'll see you guys very soon. I'm planning to do some more interesting videos on some of the system programming and function vector implementations for event callbacks and very and other interesting um, issues uh, in embedded systems programming as well as in event driven programming. So I would definitely advise you guys to stay tuned and maybe subscribe to the channel if you want to, and we will soon see each other again. Until then, goodbye.